starting with 4.1, standard position. So standard position is when we sketch angles called rotational angles of the Cartesian plane, the XY axis, with the initial arm where the angle starts as the positive x-axis. These angles can be positive if you move counterclockwise and negative if you move clockwise. So you guys did mainly positive in 20-1. So we're going to look at positive rotational angles. Your unit circle is in positive rotational angles, so it goes 0 to 360, right? So for example, for positive rotational angles, I'm going to draw and label my arms so that I know it's positive. So this is 0, 90, I'm going to do it in degrees for now, 180, 270, and then this goes back to 360. Now I want you to draw me 150. How do you think you would draw it? Draw me 150 degrees.
Two ways.
No.
Right?
No. Okay.
Negative.
I'd say negative. So 150 degrees. You have to start with your initial arm. Everything rotates around 0, 0. So your initial arm is going to be here. So to draw our first arm. And then 150 is 30 degrees up from it. So it's here. Approximately 30 degrees. And then you have to draw from here an arrow to here and say 150 degrees. I get what Marshall was saying, but there's not 2 ways to draw 150 degrees. There's 2 ways to draw that arm.
Yeah, that's what I meant.
So we can do a negative rotational angle as well. When we do negative rotational, we still start at 0 with 0 degrees, but we work clockwise. So this is 0, and this would be negative 90 degrees. This would be negative 180 degrees, negative 270 degrees, negative 360. What angle will get me to terminate on 150 on the same arm?
Negative 180. Wait.
Well,
Negative.
yeah, negative 210. Because we would want to be 30 more than this, right? For this way, we were 30 less. So we had to be 30 above this little x-axis here, right? In order to be 30 above the little x-axis, I would have to draw it here and here, correct? The problem is I'm still rotating around 0, 0. If I start at my initial arm and I go to my terminating arm, I'm going to get to negative 180 to get me to here, right? And then I have to go another 30. So this is negative 210. These are called coterminal angles because they terminate on the same arm. So they're coterminal. So it actually draws the exact same terminating arm, but different numbers, right? One's positive direction, one's negative. And there's even more answers than that. Because, let's look at the first one. If I do a whole 360, so I start at this initial, and I go around, that's a whole 360, and then I have to go another 150 to get here, don't I? Right? So I could say 360 plus 150 equals 510. And that would be the green one. And that would be another coterminal angle, wouldn't it? Right? Now, how could I get 210 easily? Negative 210. What I could have done is I could have taken my 150. I could have taken my 150. And instead of adding 360, I minus 360. Because 360 just makes me go around in a circle, right? So I can minus 360 and then I get negative 210. So for coterminals, all I'm going to do is add 360s on to my initial standard position. Standard position is an angle that falls between 0 and 360. So I can subtract 360 from that and get a whole bunch of negative coterminal angles, or I can add 360 to that and get a whole bunch of positive coterminal angles. So there are not like a limited amount of coterminals. I could find an infinite number of them, unless I restrict the domain, which we will do. All right, the terminal arm is where the angle ends And it can be in any quadrant or on any axis. So it could be like, because 90 is on an axis, 180 is on an axis. It could land on there too. What angle corresponds to each of the axes? Well, if it's in a positive rotational, we could have 0, 90, 180, 270, 360. And this would be what? 90 more, which is 450. And it can keep going, right? Forever and ever and ever, couldn't it? Positive. Or, same thing, but opposite, yeah. 0, negative 90, negative 180. So the way that people know that it's a negative angle is by you labeling these arms. Then they know you're going in a negative direction, right? Plus, if you look here, I'll show this in a second. This one I had an arrow going this way, which was counterclockwise, which meant it was a positive angle. And this one I had it starting on the initial arm going to the terminal going clockwise, so it's a negative angle. Does that make sense? Okay, I want you to sketch these. This should have a degree on it. That's it. If it doesn't have a degree, it's a radian, which is a massive radian. Because 2 pi, which is 6.14, that literally is one rotation. For 340, you'd be rotating a lot. So try and draw these. Let's draw. So, if we need 40 degrees, first thing we do is label. And we pick another color. 45 is halfway, right?
Yes.
So we're a little shy of half.
Right there.
And then we go boom, and then we go 40 degrees. We have to label that baby.
Oh, really?
Yeah. True.
Is there going to be a question like this on the test that might get more complex? Or...
I think you should know it should get more complex. It's not your first rodeo. You know what I'm saying? Okay. Then this one's 140. So this would have been all stuff you would have done last year. 0, 90, 180, 270, 360. And then we have to draw 140. So 180, so it's 40 shy of 180, so a little less than half. So I'm going to go here. That's probably not correct, whatever. And I need an initial arm. And then I draw 140.
It's actually right about half.
No, it's not. And then negative 240. 0, negative 90, negative 180, negative 270, negative 360. And then we need to be 30 shy of 270. So like here, we need an initial, and we need to go clockwise because it's negative. And then 340. 0, 90, 180, 270, 360, and then you need to be 20 shy of 360, something like that, and then it has to go counterclockwise because it's positive. I'm doing those. Good?
Good.
So that's good. It's a review of 20-1. Okay? So then, we did converting from degrees to radians on Friday, but a little revamp. You've got pot, so degrees to radians, pi on top. So we're going to go down to number 2. Convert from degrees to radians. So degrees to radians, we need to multiply by pi over 180, right? And that's how we converted all of our unit circle degrees. We multiply by pi over 180. Do I include the pi in it?
Not in the equation, you're putting in your calculator.
Right. So if I wanted an exact values, I'm not going to include the pi. But sometimes the answer's in a numeric response, and I ask for it in radians to the nearest 10th. Then you would put the pi in and give me it to the nearest 10th. So then you would go 315 pi over 180. So I want it as an exact value, and I want it to the nearest 10th. Bless you. So I want it, both of these in exact values and to the nearest 10th. So try that out. So I want a fraction that's exact values. To the nearest tenth, you include the pi. Because it depends on the way the answer is asked.
I don't know if that's right. That's syrup on my calculator. It sucks.
The thing you get on your calculator is syrup. Once you're like, I put some water on it.
Well,
Marshall's like, I put syrup.
like to wake up and do math. And in the morning, there's pancakes at my house.
And syrup.
And
Hence
syrup.
problem.
Hence calculator.
Yeah.
I like to start the day.
Okay. So, when we reduce 315 and 180, we get 7 pi over 4. And if I want to the nearest tenth, we have to go 315 times pi divided by 180. Put the whole thing in, right? And you should have gotten 5.5. Now you can write rads, you can write radians, you can write nothing. It all works. If there's no units, it's radians. Okay? So make sure you can get 5.5. If you can't get 5.5, you're probably not putting the pi in.
I'm sorry.
315 times pi divided by 180.
Can you just put like, I said the pi like
Oh,
right there, divide, is that still fine? Like,
Did you get 5.5?
Yeah.
Then you're fine.
So 315 times 5 divided by 180.
Yes.
Oh wow. Okay. See, when you said radians, I was thinking like, oh, I should just put 7 pi towards.
But then I said it needs 16. All right. 70 degrees to radians, pi on top. So pi over 180. So turn that into an exact value in the decimal for me, please.
Is it 1.22?
The nearest tenth and an exact value. So we should get 7 pi over 18. And in nearest tenth is 1 decimal 2. So one's an exact value and one's a rounded decimal, right? Very different depending on what I ask for. If I say a pi over b, the value of a, b respectively, your answer would be 718 in numeric response. If I asked it nearest tenth, your answer would be 1 decimal 2. So it depends on how the answer is asked. Now, converting from radians to degrees, I do RDPOG, or I just say it has to be opposite. So degrees to radians, pi on top. So if I'm doing radians to degrees, pi has to be on bottom. So we're going to multiply this one by 180 over pi.
Is it 420? Negative?
Should be
420.
the maturity of that.
You laughed. You laughed. I didn't laugh. I thought we.
Oh, please stop talking. Okay. So it's negative 420 degrees, and then 1.4, negative 1.4, I went to the nearest tenth, 180 over pi.
I really love this class.
I'm going to reserve my comment. Negative 80.2.
It's just like pageantry for me.
Maybe you should do a little less pageantry,
Why?
a little better marking.
What's the middle part of marking? I'm pretty good right now.
Okay.
I have 4 tests
So-
on the day. What did you expect?
So this one is a nice little part of the lesson, which has absolutely nothing to do with the rest of the unit at all. It's just a little tidbit they throw in there for fun. I don't really know why. But it's an arc length question, and it's the very top formula on your formula sheet. So it's theta equals A over R. Which is this proper to make a nice thick formation. Okay. Theta equals A over R. Now, we need to know what the heck they said. Theta is your angle. This is true, but your angle has to be in radians. So if they give you your angle in degrees, you're going to have to use degrees to radians pi on top, right? You're going to have to convert it to radians in order to use it. So do you think that on these questions they often give it to you in degrees?
No.
Yes, they do. And they make you convert it to radians to use it. Yeah?
That's what I was thinking.
Now, A is your arc length. What the heck is that? Well, you'll be given like some sort of object like this, and this is the arc length. And if you went around, this would be a full circle. This would be the radius, and this would be your theta. Now the key is, and I've never seen it not be this way, but I tell you just in case, the arc length and radius have to be in the same units. So like if the arc length is in meters, the radius has to be in meters. Yeah. Sure. Now if this was like in meters and this was in meters, the meters would cancel, and I get theta equals some sort of number without units. And a number without units is a radian, right? So that's why this theta has to be in radians. Because the units will cancel here, I'm just going to get a number. When I just get a number, it's a radian measure. Right? Right. Okay. So we're going to try this one. A pendulum 30 centimeters long. A little pendulum. 30 centimeters long. Swings through an arc of 45 centimeters. Through what angle does the pendulum swing? I want an answer in degrees and radians. You try and find theta. So we're going to get theta equals arc, which is 45 centimeters, divided by 30 centimeters. The centimeters cancel, and I get 1.5. Remember, when it doesn't have a unit, it's a radian, right? So if you want to feel better, you can go like rads behind it or radians if that makes you feel better. Now, we have radians, we want to go to degrees, right? So radians to degrees, pi on bottom, already got. So radians to degrees, pi on bottom. So I'm going to multiply by 180 over 5. When you type that in, what do you get for theta? It's in years 10. 85.9. Now, my deal with this is, if they give you theta, they're going to give you theta in. They're going to give you theta in degrees, make you convert. If they ask for theta, they're probably going to ask for them in degrees, because the answer is going to be in radians. They're going to make you convert. Okay. So you're trying out B. And it gave you the diameter. Diameter is how much the radius? 2. So your theta should be 5 pi over 6, right? Because you have to use radians, correct? So we have theta equals A over R. It's asking us for A, so we're going to multiply by R. So A equals R theta, and theta has to be in radians. So A equals 4.6 times 5 pi over 6. And what do you get to the nearest 4.6 meters? What do you get to the nearest 10th? Can you do it? 4.6 times 5 pi over 6.
You said we don't actually know.
What?
You said we don't actually know this, right?
No, that's why.
I thought you said that it was still in.
I said it's just like an extra piece that doesn't fit in with anything else, but I did not say you don't need to know it.
That's what I meant.
It's not the same thing. All right, what if we get to the nearest 10th? Okay, your homework for tonight. Number 4 wants it to the nearest 10th. Number 5 wants you to convert radians degrees to the exact value.